Okay, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1000 Pre-Calculus. So today we will be going over quiz 1. So the first quiz, make sure everyone is on the same page there, which you took on Monday. And that's the main agenda. If we have time for questions at the end, I'll also take those. But the main thing I want to do is make sure that we all fully understand all the things we needed to understand from the material that was on the quiz. So without further ado, let me get to that. I'm sharing my screen from another thing here. Okay. And so far, so good. That looks good. Let me make sure that I can see the chat here. Okay, awesome. I think we're okay. And okay. All right, so without further ado, let's actually just jump into it. So here was your quiz from last time. Questions are pasted here, and we're going to go over them. So for the first few, I just wanted to see where your heads are at. So the first few of these problems are pretty okay, I think. So we'll start there. So we're just jumping right into question 1.1. And what I will do is I will get the opinion of the class on this. So I just threw up a poll. You should see it pop up on your screen. Tell me what you think the answer is. Okay, so 2 people voting so far. So far, everyone who's chimed in, we're all in agreement. We have 1 dissenting opinion, but I'll give you guys 10 more seconds, or 7. Okay, and time. So there are the results. As you can see, 13% went with A and 88% went with B. So the majority think that the answer is B. Let's actually look at that. So the rule here that we're looking for is PEMDAS. Okay, so this tells you the order of operations. So whenever there is ambiguity, this is how you decide what the thing you actually want to compute is. And P stands for parentheses, E stands for exponentials, or exponentiation, raising something to a power. M stands for multiplication, D stands for division, A stands for addition, S stands for subtraction. So the M and the D and the A and the S have the same priority. That's something that we'll get into a little later because I actually have a few questions on PEMDAS. But when people mess up on this, that's usually where they mess up. So let's actually start with this one. So according to PEMDAS, okay, we see a bunch of operations happening here. According to PEMDAS, the first one you want to actually do is the division, right? Now, why would you do the division first? Well, there are no parentheses, there are no exponentials. Multiplication and division have the same priority, which means whenever they both show up, you do the one that's on the left first. So this would be 0 divided by 2, which is 0. Now you have addition and multiplication. PEMDAS is clear here. The multiplication gets done first. And then the addition, leaving us with answer B. So those of you who got B here, that was correct. Okay, let's move on to the next one. Launch the poll again. Let me know what you think. Probably give you a little less time for this one. Hopefully everyone's awake and now ready to participate. We also have some dissenting opinions here. Interesting. 3 different opinions now. 4 different opinions. Interesting. A lot of discussion in 1.2. Now, you guys can't see this because I guess they don't want you to see the polling while it's going on because it might influence your decision. But actually, as the person who posted the poll, I can see in real time how people are voting. And it's really interesting to see the bars moving up and down. Yeah, you can see it right here. It's like these little bars here keep moving. Oh, flip the screen by accident. But let's stop there. That's more than enough time. Here are the results. So you can see the results. So there are 4 possible answers that people have picked. 20% went with A, 7% went with B, 67% went with C, and 7% went with D. So it seems like the majority believe that the answer is C, which is 29. Let's actually see how that would work. So again, the idea here is PEMDAS. So according to PEMDAS, you would work out what is in the parentheses first. So we're going to worry about what's inside here. Now, what's inside there, that also has a pair of parentheses inside. So you'd actually work out what's inside those parentheses first. So the 7 minus 5 is the first thing you would do. That's 2. The 20 minus 19 you would also do, which is 1. So that's that. Now, according to PEMDAS, you stick with working out what's inside the parentheses. The next thing you're going to do is the actual exponentiation. So you're going to take 2 to the squared, 1 squared. Keeping with PEMDAS, we're still simplifying what's in the parentheses. Now, with that said, we now have multiplication and addition. According to PEMDAS, the multiplication comes first. And so we end up with 29, which is C, where the majority of people were, but there are a few of you who didn't get C. Moving on to the next one. I'll work out this one for you guys. I'll throw polls up for 1.4 and 1.5 for historical reasons, but let me just go through this. So again, it's a matter of PEMDAS. Which means I'm going to work out what's in the parentheses first. Okay, and maybe I can have someone chime in here actually, try to help me out. So in the first pair of parentheses, what would you do first? What happens first?
You would do what's in the parentheses first.
Which is?
Which is 2. And then.
What 2? The 4 minus 2?
Yes.
Right?
And then you would do exponents, so 8 squared, 64.
Okay, so that's 64.
And then next is multiplication or division. We have division, so 2 divided by 2 is 1. And then.
So that's just 65,
Yeah.
right? Now the second one, you just actually just distribute here. That's a 3 there, and then you end up subtracting a 9. So it's 65 minus 9, and that is 56. That's A. Yeah. All right, so I've relaunched a poll for 1.4, making sure you guys aren't asleep on me. 1.4. Let me know what you think. We have disagreement as to whether the answer is 1 or 9, it looks like, which is actually expected. Believe it or not. 2 people left to vote. I'll give you another 10 seconds. One person left to vote. 2 seconds. We're not going to wait. Polling end. Share results. There you go. You should see the results now. You see that the majority believe that it's A, but that's only actually 72%. We have 28% believing that the answer is C. So the majority of people believe that the answer is 1. Let's actually see. So according to PEMDAS, what should happen first? Someone can tell me here?
Division.
The division. And if you divide that, how do we do the division?
You'll do 3 times 3 over 1. You do keep, change, flip.
Keep, change, flip, exactly. So this would become 9 minus 3 times 3 over 1. And so you would actually do the division first. That will give you 3. Not 3, 9. 3 times 3. And now you take the 9 minus the 9 and add the 1, right? And that's because addition and subtraction, same priority. So when they both show up without parentheses, you do go from left to right. So the left is a negative sign. So that's 0 plus 1, which is actually 1. So that's actually 1. $1.5, poll is up. Get your votes in. Exercise your rights. So far, people are more certain about this one. 3 people left to vote. 1 person left to vote. Maybe that person is actually, oh, they voted, awesome, 100% polling. And those are the results. So for a while there, C was way ahead. There was like 90% of people, but a lot of people came in with responses of B afterwards. So 79% believe that the answer is C, it's actually 9, while 21% believe that the answer is B, which is 1. Let us see what the answer is. So again, it's PEMDAS. So PEMDAS is saying that you should do what's in the parentheses first. Okay, what do we do now?
Division.
You have to divide.
You do.
You have
Who
to
said oh? Did a light bulb go off? I don't know. So division is what happens next. And again, why is that? Because multiplication and division have the same priority. Perform from left to right when both appear. So that's the rule about PEMDAS that people often forget. So a lot of people know what the individual letters stand for, but they don't know that the M and the D and the A and the S are kind of paired together. And it's just customary that whenever the M and the D appear together, the guy that's on the left goes first, not the guy that's in the left in PEMDAS, the guy that's in the left in the problem itself. So here division is on the left, multiplication is on the right. So this is on the left. The multiplication is on the right. So the division happens first. So the answer is 9. Now, these last two, I gave you guys a poll because they're examples of a couple problems that, you know, those simple problems that break the internet or whatever, when it pops up every now and then in my phone, you know, this math problem is dividing the internet, and, you know, people are disowning members of their family because they disagree on answers and all sort of stuff. And I'm not inviting them to Thanksgiving again, right? So it's like everyone's like has disagreement about the answers, and oh, the 4th grade math problem stumps the internet, right? So these are actually two problems like that where there was like a big thing. One of the other ones was actually in the meme that I put at the end of the thing. Where is it? Yeah. So this was one that I did in class. You guys might have recalled if you watched the lecture that actually discussed this problem. It's actually very similar to the 6 divided by 2 times 2 plus 1 problem that we did earlier, where there was big disagreement. And even in the class, I had students disagreeing, and I had people really giving other people the evil eye. I'm like, you guys are too passionate about this. But the error in that people make when doing this is that they keep forgetting that division and multiplication has the same priority, same with addition and subtraction. So yeah, these are actually two famous problems. Like, you can actually search the internet for these two problems and you'll see like people warring on Twitter about it, as well as the guy in the last part. So yeah, I was interested in seeing what you guys thought. And yeah, the two answers that you guys were disagreeing on were the same two answers that people were arguing about whether or not which one of those were the answers. So yeah, it's very interesting. The majority of you got it right, but it was 70+%. So hopefully by the end of this lesson, by the end of today, you guys are better at doing that, getting those more accurate. Okay, so for the rest, just to make sure that we finish in time, because we have a few problems to get through. I will just, from now on, I won't be doing any polls anymore, but I'll actually just take your inputs. So you guys can chime in whenever and let me know. Question 2, right? Suppose we wanted to evaluate this expression. What operation would be the first step?
Division.
Division, right? Again, because of PEMDAS, what is inside the parentheses is going to be considered first, and inside the parentheses, you have addition and division. D comes before A, so division is actually the first one. Division will be the first thing you would do. So the first step in this problem would be to divide 8 by 4 to get 2. Question 3, in what order would you take the steps to evaluate this? What's the first thing that would occur here?
Parentheses.
Parentheses.
What's inside the parentheses, right? So that's the first thing. What's the next thing?
Division.
Division. Because of PEMDAS, notice that there's both a multiplication and a division. They're the same priority, so you read from left to right. So the division will be the next, then?
Multiplication.
Multiplication, which is that, then?
Subtraction.
Then finally the subtraction. So now we look for PDMS. That's this guy.
I have a question about that one.
Yes.
Why is it that you don't consider addition one of the steps? Because that's inside the parentheses.
Yeah, that was my P. Yeah, work out what was inside the parentheses. Yeah. Addition wasn't one of the thingies here. The parentheses implied the addition. Okay, What about this? A over B times C over D. How do we do that? What is that?
AC over BD.
AC over BD. Yeah, that's actually a rule. So this was a rule that I went over with fractions with you guys. So whenever you're multiplying two fractions, you just multiply across the numerators and the denominators. What about adding two fractions? What is the rule for A over B plus or minus C over D?
It's AD plus minus CB over BD.
Right. So which choice is that?
None of the above.
None of the above. So that was 4.2. We're on a roll. Let's keep going. Rule for dividing fractions. I believe we mentioned this earlier.
Keep, change, flip. So
Keep, change, flip. Keep the
AD.
first one, change the sign to multiplication, flip the second one. And how do we do that?
Just like the multiplication above. So it's AD over BC.
Yep. Is that here?
No.
No.
No, none of the above. Finding LCD, the least common denominator. Notice that LCD, this just means it's actually the LCM of the denominators. And LCM means least common multiple. Okay, so how do we find the least common multiple? Someone describe to me, how do we find them?
With the prime factorization.
Prime factorization. One, find the prime factorization of each number. Okay, so there's a very important theorem in mathematics that says every integer has a unique prime factorization. And this is one of the main reasons why we don't consider one a prime number, because it would spoil that. But the idea is every integer that you can come up with, besides if you don't consider the negative sign, there's a unique way to write it as a product of prime numbers. So when you do that, you can write, that's called a prime factorization. So for example, the number 15, you can think of it as 3 times 5. There's a way to actually break it down to a multiplication of integers that cannot be broken down into any smaller pieces. Once you do that, what's the next thing? So I find the prime factorization of all the numbers, then what? What do we do after that? Anyone?
I think you just take the highest. Well, if it's like 3 and one of them has 3 squared, you would take 3 squared. I don't know how to explain it in Word, but that's what I did.
Okay, so the LCM is equal to the product of all primes that appear raised to the highest powers to which they appear. So that's how you find the LCD. Well, the LCD is just doing this for the denominators that you see. Okay, so if I have 1 over 15, 1 over 18, 1 over 30, I believe those were the numbers. Yes. So now the LCD is just equal to the LCM of 15, 18, 30. How do we do that? Well, for each of these, we're going to consider their prime factorizations. So 15 is 3 times 5. 18, you can think of this as 2 times 9, or 2 times 3 squared. 30, you can think of that as 2 times 15, the same as 2 times 3 times 5. So these are the prime factorizations. So what you realize here is that the primes that appear well, the 2 is a prime number, 3 is a prime number, 5 is a prime number. And so your LCD is going to be 2 times 3 times 5, but you're going to raise it to certain powers. So what's the power of 3 here? Well, it's a 1. The power of 5 is a 1. The power of 2 is a 1. The power of 3 here, you'll notice that's a 2. The power of 2 here is a 1. Two here is a 1. The power of 3 here is a 1. The power of 5 is a 1. So what are the largest powers? So notice that 1 is the largest power for the 5. 2 is the largest power for the 3. And 1 is the largest power for the 2. So I just look at all the lists that I have, and I'm going to pick out the largest powers. So the highest power for the 3 is 2. The highest power for the 2 that appeared is 1. The highest power for the 5 that appeared is 1. So this just becomes 2 times 9 times 5, which is 90. So that's the LCD. There's an alternative here. Alternative. It's a bit clumsier, but it works. Is clumsier a word? Is to actually write out the multiples. Pick the least common one. Least as in smallest, not the one that's the least common. So you have 15, you have 18, you have 30. So you're just going to actually write out the multiples. So the multiples of 15, 15, 30, 45, 60, 75, 90, 105, 120, etc. What are the multiples of 18? There's 18, then
36.
36, then
54.
54,
then
72,
then
90,
then
108.
Okay, keep going. What about 30? It's 30, 60, 90, 120, right? you'll notice that 90 appears in all of these lists, and it is the smallest number that appears in all of the lists. So that's your LCM, which in this case is the LCD because their denominator is over fraction. So that's why that's 90. Okay. Now, that concept of how to find an LCD applies to even when you can't really see numbers. So for example, here it would apply to just us using variables. So one denominator is x, the other is x to the fifth, the third is x to the seventh. What's the LCD?
X to the
X to the
7th.
seventh.
X to the seventh. You just pick the one with the highest power because of the same principle before. You can think of the base. Think of base as the prime factor. Pick the largest power, because that's the rule.
I have a question.
Yes.
Does that apply? It doesn't apply if it's like instead of x, 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 it's x, y, z.
The general principle always applies. This is always applying.
I know I'm talking about question 5.2 specifically.
Yeah. So let's actually go through 5.2. So if this were x, that were so you're asking the question, what about 1 over x and something like 3 over y to the fifth and something like 7 over z to the seventh, like that?
Yeah, that one apply.
Yeah, so the primes, what are the primes? Well, the
No, I'm
x,
talking
y, and z. So
So
then
the-
the LCD would be each of those guys multiplied together, but you raise them to the highest power to which they appear.
but yeah, I know about the LCD. I'm talking about, you know how we said
5, not 1.
x.
5. Yeah, what were you saying now?
So if it's 1 over x and 3 over x to the fifth and 7 over x to the seventh, we picked x to the seventh because the base is the same thing.
Yeah,
But if it was the one that you did, the 1 over x, 3 over y to the fifth, we can't just pick z to the seventh, right? Because it's not the same base.
right. So
Okay,
you have to
just
write down everyone that appears, right? So when, like in this example, when we had 3, 5, 2, like I had to write down everyone that showed up one time, right?
Yeah.
So I can't just ignore the x and the y and just write down the z. Like I have to write down every base that appears has to be written down, and then I write them to the highest power.
Okay.
So when we're looking at x, x to the fifth, and x to the seventh, there's only one base. It's only x. Then I pick the highest power, so it's x to the seventh. So all the bases need to be written down, but then you just write them down to the highest power.
Okay.
And of course, if the bases have nothing in common, the LCD is just the product of all of them. You can also note here, LCD equals product of all bases if, because that's not true in general, if product of all denominators. If bases are not the same. Or let me say it in the sense the bases have no common factors. So here, if I had an x if I had an x, then a y to the 5th, and a z to the 7th, those guys have no common factors. So the LCD is actually just the product of all of them. But still, it's still obeying this two-step rule that we have here. That's always the one that you're going to obey to figure out the answer. Did I already cut that? Okay. So here's 5.3. Okay, someone walk me through this. Let's see if we're getting what I was saying earlier. How do we figure out the LCD for these two fractions?
You find the LCD of 9 and 21. The
Okay.
prime factors of 9 and 21.
So you do the prime factorization. So for the 9, it's 3 squared. And for the 21, that's 3 times 7. So then, what do you do?
It's going to be 3 squared times 7.
Right, the highest power that the 3 appeared to is 2. The highest power that 7 appears to is 1. Then?
And for A and B and C, you take the highest power, which is in order 4, 7, 8.
Right. And then if, so now here I'm just simplifying. 3 squared times 7, that's 9 times 7. That's actually 63 to the 4th, b to the 7th, c to the 8th. That's A. Right. So once you learn those principles, you can apply it to more and more complicated things. And that in and of itself is a principle that will be repeated over and over in this class and in many other math classes as well, etc. Learning the basic foundational principles, super important. It's why I started the class off very simple, to build the foundation from the ground up. Because as you will see, complicated problems are really just simpler problems, a combination of simpler problems. Not always true, but in pre-calc, it's pretty much always true. Also in Calc 1, in Calc 2, and in the entire calculus sequence, that's always true. That's true in math for a while. You never really get to super interesting problems until afterwards. Okay, so we're moving on to problem 6. Express the inequalities in interval notation. So this is just a notational thing. I gave you guys a huge table in class where we actually did the notation. So let's start with the first one. How do we denote that in interval notation? X less than or equal to -1.
Parentheses, negative infinity, comma, -1, close brace, or bracket.
And this one?
Open parentheses, 2, comma, 3, close brace. Oh, still bracket.
And this one?
Parentheses, 5, comma, infinity, parentheses.
Yeah. And how do we use the or?
With a U.
Right, so it's like a big U, right? And by the way, this is the inclusive or. I mean, it's the only one we'll talk about for a while. We'll never use the exclusive or in this class. Exclusive or, you'll put a little dot over the U. So this means so A or B means what is in A or B or both. That's called the inclusive or. So yeah, we'll just put a U between each of these symbols that you just told me. And that looks like the first option. That's that one. Let's keep going. All right, this one. Ideas?
The 4 is, the dot above the -4 is inclusive.
Yes, it's
so
totally.
it doesn't really matter.
Right.
So you can look at the dot above the -2, which doesn't include it.
Mm-hmm.
So, and it goes all the way. So it's open parentheses, -infinity, comma, -2, close parentheses.
Close parentheses.
Open parentheses.
Open parentheses.
The
right?
close
And that-
parentheses, not close brace, is what I,
Oh yeah, yeah, okay.
just because.
Oh,
it's-
I get what you mean. Yeah. Sometimes
Open
people call the brackets close parentheses, and we call the parentheses open parentheses. Yeah, it's a language thing.
That's confusing.
Yeah, I know. Okay, so that's the first part. So yeah, the -4 is actually included. So when you have this, it's like you're saying -4, it's included, or -4 included, right? It's just you have the -4 is included anyway. You can just stitch these guys together, right? You don't have to skip over the 4 because it's actually filled in, right? Continuing to the other side. What is that going to look like?
That's an open bracket, -1, comma, 0, close parentheses, because the 0 isn't included. And then U, open parentheses, 0, comma, infinity, close parentheses.
Right. And then you put a U in between all of these guys as well. So this part is here, and this part is here. And do we see that? Yeah,
The third one.
option C. By the way, if you guys are having any questions, you can, you just stop me. I'm asking for input. That also includes if you have a question. Next problem, domains. So here we want to find the domain of a function. And like with the whole finding the LCD thing, the principle applies here. You really want to know how to find domain of the pieces, the fundamental rules, and then you kind of extrapolate that to the more complicated combination that makes up this function. So something that you'll see in the domain here is the square root. So now this makes you want to think, if I see the square root of x, what is the domain? Square root of x, what is the domain? How do I describe the domain?
It means x needs to be a positive number or 0.
Right. X is greater than or equal to 0. Or you can write it as right? So just remember domain. Let's see what we know that means. What does domain actually mean? Like if you were to describe to me when I ask for the domain, what am I asking for?
The range of numbers you can input that will allow the problem to make sense mathematically.
Right. So set, I wouldn't use range because the word range is actually used for a different thing. So the set of possible inputs that allow the computation to make sense. For us, make sense means it is a real number. So there is a way to make sense of having a negative under a radical, but it is outside the scope of our class. That puts you in the realm of a set of numbers called the complex numbers. We are not doing complex numbers in our class. So for us, make sense means I can plug it in and get a real number output. There is some number, there is an answer that I can actually plot on the number line that we're used to. So that's what that means. Now, when it comes to the square root, the things that make sense are things that are 0, square root of 0 is 0, which is a real number, or anything bigger. Square root of a negative number doesn't make sense in our concept of the world right now. So that's what we need for the square root. So in that same vein, if we focus on this part, what do we need to happen in order for this to make sense?
We need x minus 1 to be greater than or equal to 0.
Or that's the same as saying x is greater than or equal to 1. Okay.
Yep.
Now there's another part. There is another radical right here. For the radical of 2 minus x, by a similar token, we would need 2 minus x to be greater than or equal to 0. And so your x would have to be less than or equal to 2. There's another thing to consider. This whole part here. There's a 1 over the radical of 2 minus x. And what is needed for that?
The radical of 2 minus x cannot be 0.
Right, so the 2 minus x cannot be 0 either because you would divide by 0. But the square root of 2 minus x should work. So it can work, but it cannot be 0. And again, that's because of another basic rule, right? So we know that if you have a over b, then the domain is given by alt b not equal to 0, but makes sense otherwise. Okay. So there are 3 things we need here. Notice here, to say that 2 minus x is not 0, my x cannot be 2. So how do you actually put this all together? At this point, what you do is you look at the overlap. So you look at the individual pieces, which individually, they're all very simple to deal with if you know the rules, the domain rules that I gave you. And basically what your goal is right now is to get all of these requirements fulfilled all at once. So if you look at just the number line, there are a bunch of guys that show up. Of course, there's the 1 shows up, the 2 shows up. And what do we need? Well, for the square root of x minus 1, I have to be greater than or equal to 1. So that means I can be at 1, so there's a shaded circle, or anything bigger. Okay, so that's fine. For the radical of 2 minus x, I need the x to be less than or equal to 2. So 2 is fine, and anything less. And to make sure that the denominator of the fraction works, the x cannot be equal to 2. So for that requirement, 2 is not allowed, but anything else is allowed. Now, what is the domain of the entire function? Well, It is the set of numbers that satisfy all requirements at the same time. This means that we care about the regions where all of 3 of these colors appear all at once. And what region is that?
The bracket 1, 2, parentheses.
Right. 3 colors appear over here. So that's the overlap. Right? Notice that where the 1 is included. However, the 2 is not included in the third one, and so you cannot include the 2. So the overlap is just, it includes the 1 going all the way up to 2, but not including the 2. And that is our answer, which is third choice. Okay. So it looks like a big complicated function, but as I mentioned earlier, complicated problems are just a combination of simpler problems. If you really understand these 2 things right here, you understand how to do the larger problem. Maybe someone besides Ariel can help me out with this, because Ariel has been relying on him too much. It's another domain problem. Tell me what you think the answer is. How do we get to it? What do you consider?
X in the numerator has to be either greater than or equal to 0.
Okay. Yeah. So for the numerator, yeah, we need the x to be greater than or equal to 0, right? Because that gets the square root to work. So the numerator is going to work there. Yeah. Now what?
And then for the denominator, because you can't divide by 0, it has to be greater than, the x minus 1 has to be greater than 0. So if you solve that, it will be x is greater than 1. X has to be greater than 1.
Not quite. No, there's an issue here. What's the issue? Maybe someone can help them.
For x minus 1, isn't it supposed to be equals to 0?
Well, the opposite, right? Not equal.
Mm-hmm. Oh, yeah.
Right. Which means it can be greater than 1 or less than 1, right? And that's actually a very important distinction, because the problem is going to be incorrect if you have the greater than sign there versus the less than sign. So now what we do is we look for the overlap. Well, on our number line, the numbers that show up are, well, first thing that we have to worry about is x must be greater than 0. So if there's a 0 here, greater than or equal to 0 can be that or anything larger. Second thing we have to worry about is the x cannot be 1. So 1 on this number line, I'm not allowed to be 1, but I can be anything above or below. Now, in the first case, when we went to greater than sign, we only had half of this. We only had the above. So we would have missed some of the overlap. There is some of the overlap that's actually below 1. And then there's overlap above 1 as well. So that guy is going to be, well, 0 can be included in both, but anything bigger than 1 can be included as well. And so that leads you to this. Are we getting it? Are we understanding the principle here? Figure out the individual domain pieces and then find their overlap. Forge ahead. Let's keep going. I think we're making okay time. Our class ends at 3:45, correct?
Correct.
Yes. All right, so this one is asking you to find and simplify a difference quotient. This is actually something we spoke about in the first class, our first Zoom class, and then I think you went over it in the online class as well. So I guess I can start this off. F of x plus h minus f of x all over h equals. All right, what do we plug in? What happens here? So this is f of x plus h, so that's x squared minus 2x plus h minus x squared minus 2x, yeah? Right? Agreed?
No.
No? You don't agree with me? What do you mean?
You need parentheses.
I need parentheses where?
So
Oh, I see. I missed the parentheses here. So now it's fine? Because of course, after the negative sign, you have to open parentheses.
yep, but also
Hello?
It's supposed to be x plus h parentheses squared minus 2x.
Like that?
Again. Yeah,
So that's good. Are we good now? Can we move forward?
I believe. Oh no, sorry. The minus 2x, you put minus 2 parentheses x plus h.
Okay, so remember the principle. F of x plus h means everywhere you see an x, you replace it with parentheses x plus h. All right, so that's actually the correct first step. I deliberately made a couple of errors on purpose because I see those errors all the time, but hopefully we're getting beyond those now. Okay, so the next step would be to work out what the x plus h squared, that's just x squared plus h squared. Yeah? Now what? What's the next line?
So you're gonna combine like terms, right?
What like terms?
So like x squared you would subtract the x squared further down on the numerator, and then so that would just be 0, and then you would have h squared minus 2h over h, pretty much is what you're left with.
So I would cancel these, and I would have h squared minus 2h over h.
Yeah?
And then I can cancel the h's like this?
No.
No. Okay, then what?
I mean, you can factor out an h in the numerator, and then you can cancel the first h with the bottom h, and then you're left with h minus 2.
And there is no h minus 2. So it's none of the above. Incorrect.
It's wrong.
No.
It's wrong. Where is the
Because
mistake?
you distribute the power, the second power, to h plus x wrong. It's not x squared plus h squared.
What is it?
It's x squared plus 2hx plus h squared.
Exactly. Why did you guys miss that? I was thinking if someone's going to tell me, you're crazy, Jhevon. That's not how it goes. But alas, I slipped the mistake right past some of you. So that was not the correct second step. To expand x squared, x plus h all squared, it's x squared plus 2xh plus h squared. Be careful, right? So what I did was a very common mistake. I mean, I said it, and some people didn't even catch on to it because it's something that's very common to make that mistake. But that would be the correct next step. At this point, we followed the process that we did last time when we had the incorrect thing. You combine like terms. So the x squares die. The two x's die. And we have here 2xh plus h squared minus 2h all over h. So at this point, I can cancel the h's?
No, you factor.
Right, no. You factor out the common h.
Yeah.
And at this point, I can cancel the h's. So now this becomes 2x plus h minus 2 is the answer. And that's our guy right there. Be very careful. A lot of common mistakes happen with problems like this, but I warned you about them. Don't make them. Question 9, problem 9. Isn't so bad. Maybe someone can quickly tell me how to go through problem 9. What do we do?
There's an imaginary -1 between the and then you distribute to like negatives.
This guy right here? Okay, and what would we get?
And then you distribute, and then you get 4c to the fourth plus 1 minus 7 c to the third, and then plus 3, and then plus 2c to the fourth plus 5c to the third.
Then?
And then you combine like terms, which would be 6 c to the fourth, and then plus 4 minus 2 c to the third.
Okay, and that leaves us with 6c to the fourth minus 2c cubed plus 4. Looks like the second option. That's correct. Just combining like terms. Okay, so problem 10 was just a general algebra problem. Just to see how you guys are reasoning. It wasn't meant to be difficult or anything, just meant to actually just get you guys to think algebraically and think in terms of principles. So a bat and a ball costs $3.50. If the bat costs $3 more than the ball, what is the cost of the ball?
First, you have to set up. You're going to set up a system of equations. X plus y equals 3.5 for the cost of the bat and the ball.
Okay, so what are you calling the cost of the ball?
X.
So let x equals cost of the ball. Now, you could set up a system of equation with a different variable like x and y, but that's not necessary here because we do know how to write the cost of the ball, cost of the bat in terms of x. what would that be?
X plus 300.
X plus 3,
Well,
right?
or cents.
Yeah, but all the answer choices are in dollars, so I'd probably keep things in dollars.
Okay.
And so this means that if I take x plus 3, that is 350. So that's like your x plus y equals 3.5. And at this point now, you just solve for x. So it's 25 cents, which is not present. Turns out, people choosing 50 cents would be a common error. In fact, this is another problem that has historical significance. This is one of those problems that it's actually very famous for being in some sort of university entrance exam where a lot of people got it wrong, and so it became this major thing of study. I believe it was Oxford, I don't remember, but it's decades ago. And these weren't the numbers that were used. It's actually $1.10. So the question was, a bat and a ball cost $1.10. If the bat costs $1 more than the ball, what is the cost of the ball? A lot of people, their knee-jerk reaction is just to choose 10 cents because, oh, it's $1.10. But if you actually think about that, that would not be the correct response, because if the thing costs 10 cents and this thing costs $1 more, it means it costs $1.10, so that when you add them together, you get $1.20. So similarly here, I just changed it to 350 instead of 110, but it's a very easy error to actually make. Just wanted to make sure that we are thinking of things systematically. We are in pre-calculus after all. We should know how to think algebraically. And these are kinds of thinking that I will go over as well with you guys to make sure that we are up to speed on this kind of thinking, how to really set up a problem mathematically so that you don't just end up in the wrong situation on a whim. Yeah, so those are all the problems that I expected you to be able to do after going through the lectures. However, there were some bonus problems here, which technically you wouldn't know how to do, but chances are you might. So I'll probably just go over the bonus problems very quickly. If you don't get them, don't worry. Future lectures that you will be watching will allow you to know what the answers are. So let's actually just go through these quickly with very little explanation, because we only have a few minutes to wrap up. Anyone can tell me the answer to this one? A is an expression, has 4 terms. You want to factor it. What's the first thing you want to look for?
GCF.
GCF. It's in fact a trick question. GCF is always the first thing you look for when you factor. A lot of people think that once you see 4 terms, it's factor by grouping. You pair them off and you factor in groups. No. The first thing you look for when factoring any problem is the GCF. It's literally always the first step.
What does GCF stand for?
Greatest common factor.
Thank you.
Now, that's like here, when we factored out the H was the GCF. It was the greatest thing that was in common. You actually find the GCF very similar to how you find the LCM. The difference is you actually take the lowest powers. But yeah. Problem on sets here. What is the union?
Union A, B is the second one. 1, 2, 3, 4, 5, 6, 7, 8.
Right, it's the second one, right? It's elements in A or B or both. Those are all the elements that show up in either or both. By the way, if I were to ask you what the intersection is, BTW. If I ask you A intersected with B, what would you say?
The empty set.
It's the empty set. They have no intersection. So the third choice is actually the intersection. Did anyone figure this out? Did anyone try this bonus?
I did.
What did you think the answer is?
Open parentheses, 0, comma 1, close bracket.
Mm-hmm. That's it. And the idea was these are all intervals. So if you started drawing out a few, you would probably have noticed. So let's pretend 0 is here. The first set is open at 0, closed at 1. Second set open at 0, closed at 2. Third set open at 0, closed at 3, etc. Right? And it keeps going like that, etc. And you just want the overlap between all the sets. You'll notice that all the sets, no matter how high up you go in the ladder, they will all include 0 to 1 inclusive. So that was the overlap. I believe the next thing I asked for was the union. Yeah, so it was the same problem, but I asked you for the other thing. I asked you for the union. So using the same picture probably. So the union doesn't care about overlap. It just cares about anything appearing anywhere at any time. So the numbers over here, for example, are in the union, even though they're not in this set over here. So
Just
what
a
would
question
the union
about your
be?
picture, Jhevon.
Huh?
The 3 and the 4 you didn't fill in.
Oh, yes. Right, so what is the union?
0 to infinity.
0 to infinity, right? Because it's going to keep going. It's going to go all the way up to 5, then all the way up to 6, then all the way up to 7, then all the way up to 8. And it just keeps going. It's like I'm counting all the numbers with the sets. It's going to go off to infinity. Okay, so this is a few lectures away, but again, it's another thing that a lot of you might actually know how to do. But we have a minute left, so I guess I'll just walk through this one. So first of all, you would flip this. You'd replace this with multiply by x squared. Multiply by x squared plus 6x plus 9 over x squared plus 6x plus 8. And so the trick here is you want to factors everyone first. So the first one is x plus 1 times x plus 2 over x plus 3 times x plus 4 over x plus 3, x plus 1, it looks like, times factoring x squared plus 6x plus 9, I believe that's x plus 3 squared. Factor x squared plus 6x plus 8. I think 4 and 2 would work. And then you cancel the common terms from the top and the bottom. So x4s are gone. This x3 cancels one of those. This x3 cancels the other one. This one cancels that. X plus 2 cancels that. Notice everyone cancels. So you actually just left over with 1. So that all simplifies to 1. So we're pretty much out of time. We will stop there. As always, I will post a video with the PDF of these notes that you see here. I had some issues editing the video of our last class, so that's why it hasn't been posted, but hopefully I get to post that soon. But for now, that is it. That was quiz 1. Covered a lot of important topics, a lot of important principles that will apply from now until forever. So be sure to keep those principles in mind. I know we're still at the looking at very basic things, but they're important basic things. So we will stop there. thanks for your participation. Thank you for showing up, everyone. Have a good day. If you have any more questions, you can, of course, email me and we can deal with it. Without further ado, I guess I'll let you guys go. So
Thank you.
yeah.
Thank you.
All right. Take care. You're welcome.
you.
You're welcome.
Thank you.
Have a good day. And
Thank you.
yeah, see you guys in the next one.